2011. You guys are on text page 264 and your blue notebook page 256. We're on lesson 5.1, and you guys were to write down with a example angle of depression and angle of elevation. And I'm quickly going to draw one out for you. Okay? The angle of elevation deals with, let's imagine someone is standing here. Standing and he's looking up at something. This would be the angle of elevation. So say they gave us it was 50 degrees. The angle of elevation from where he is 50 degrees upwards. So if you have to create a triangle, that would be the angle of elevation. Or let's say he is a giant. And he's standing over people. That's not one. The angle of depression is from where he's looking down. So if you had to create a triangle where someone says the angle of depression is, let's say, again, 50, the triangle, or your right angle triangle, is going to look like this. So angle of depression would be looking downward. Elevation is looking upwards. Okay? So make sure you guys understand that idea for when you have word problems with this. So today, we're going over basic trig, what do they call them in the book? Applying the primary trigonometric ratios. All that means is today we're just dealing with right angle triangles. So make sure you have in your head that we are only dealing with right angle triangles. These only work with right angle triangles. I'm going to say it 4 times. Right angle triangles and right angle triangles. Do not try these with triangles that are not right angle triangles, because these ratios will not work. So Matthew, when do these work? That's right. Very good. So, like I said, right angle triangles. You guys may have learned this in the past as SOHCAHTOA. It's an acronym, but there's a special name for it to remember these. Anyways, SOHCAHTOA refers to our 3 trig ratios. We have sine theta, cos theta, and tangent theta. The very first thing we have to figure out is how to label a triangle before we can even go into sine, cos, and tangent. So, once we have our right angle triangle, and assuming you guys can tell where the right angle is, there are 3 sides to a triangle. There is the hypotenuse, which is the most important one that I want you to make sure you know. It's the first one you always have to find. It's always opposite of the right angle. So this is our hypotenuse. And on top of that, it is always the longest side of the triangle. Okay? So, if you still were unable to figure out where the right angle is, or you can't for some reason figure out what the opposite of the right angle of the triangle is, you can measure all the sides of the right angle triangle. And this, being the longest, is our hypotenuse. Okay? So, make sure you can always find your hypotenuse first when you're going to deal with these. The next things we're going to talk about is opposite of an angle and adjacent of an angle. Those two both change. A hypotenuse will always be the hypotenuse. No matter where the angle is you're working with, it will always be the hypotenuse. It is always the longest side of the triangle. But let's say we're working with this angle here at the top. Okay? If I'm working with this angle at the top, the opposite side of this, I don't know why this is funny. There you go. The opposite is, once again, opposite of that angle. So this is the opposite side. And the adjacent side is the side that is touching the angle, but is not the hypotenuse. The hypotenuse will always be touching either the angle we're working with. So this is our adjacent. Not yet. Okay. Do you guys have any questions about that? Okay. All right. What I'm going to do is, let's say we're working with the other angle now. So take those all away. Let's say we're working at this angle on the triangle now. Okay. The opposite side of the triangle is now over here. The side has changed. This is the opposite side of the triangle. And the adjacent side to this angle is right here. Remember, there will always be two sides of the triangle touching the angle. The adjacent side is the one that's not the hypotenuse. Okay? So, specifically for our sine ratio, we'll be using sine theta. We'll call theta the angle. That's what that means. So maybe they'll call it x in your book. Usually call angles theta. So sine, and then whatever our angle is, this represents the angle, this theta here, is equal to the length of the opposite side divided by the length of the hypotenuse. Okay? So if we were to set up this ratio, sine theta, opposite over hypotenuse. The next ratio we work with is cosine. Now, instead of doing this twice, I'm just going to draw it once. First of all, hypotenuse, still the exact same spot. It's still the longest side of the triangle, and it is still opposite of the right angle. Now, which one did I end with? Okay. Let's say, actually, you know what, let's go back up. I just want to circle two things. So, what that means from above with our sine is the two values that I need for sine theta are the opposite. So I need the length of this side and the length of this side. Even though this is the adjacent, I don't need it for this ratio. This ratio only deals with the opposite and the hypotenuse. So let's go down. We use the same angle with a different ratio this time. So we have our hypotenuse. I know that this will be the opposite side because it's opposite of the angle. We'd already figured that out above. And this is the adjacent side. But in this, that's not how you spell it. C-E-N-T. Oh yeah. Well, I'm really off today. Okay, so we have our adjacent side and our opposite side. When we're using cos theta, we need just the opposite, just the adjacent and the hypotenuse. So the two sides of the triangle we need are the length of this side and the length of this side. So just to compare the two, if you look again, our sine theta dealt with opposite and hypotenuse, so that's this side of the triangle and this side of the triangle. Don't worry, that'll all disappear. With our cosine, we needed adjacent and hypotenuse, which is this length of the triangle and this side of the triangle. Okay? So we're dealing with different sides of the triangles depending on which ratio we're working with. The triangle is still labeled the exact same. So let's go down to tangent. If we're going to go work with tangent, once again, very simply, this is still the hypotenuse. Has not changed. Still opposite of the right angle and still the longest side. We're still going to work with this angle here. The opposite of it we know is across. And the adjacent is touching it, but not the hypotenuse. Finally, for tangent ratio, we don't need the hypotenuse. We need the length of the opposite side and the adjacent side. Okay? And that's for our tangent ratio. So once again, that one's different from our cosine and sine. Finally, I just want to make sure that you guys understand one other formula. It's called Pythagorean Theorem. A squared plus b squared equals c squared. Okay. What this formula means is if you take one side of the triangle and square it, add it to another side of the right angle triangle and square it, it will be equal to the hypotenuse squared. C represents the hypotenuse. So this would be our C, which is our hypotenuse again. We know how to label it. We've done this 4 times now. A and B doesn't matter. I could put this side as A, or this side as A, and the opposite is B. Okay? So if I was to label this triangle, when I go to plug in this formula, I know the hypotenuse is equal to C. That's the only one that's extremely important. They have to get right. The other two, it doesn't matter what I call A and B. The formula will always work out. So before we keep going, so right now for the next 5 or so minutes, go into your blue notebook, page 252 and 253. I want you to try the few questions on that page. All right?